So 7.1 is ratios and proportions. Our objective, which goes on the top of your guided notes, is to use rates and proportions. So that should be what's on your notes right now. Okay, so ratio. I have a definition of ratio for you. Jeremy? So a ratio is a comparison of a number and a non-zero number using division. So here we see we have 4 to 7. It's written as a fraction, but we read it as 4 to 7. We can rewrite it in 3 different ways. So you have A to B, and A, notice it's a colon, to B. So each of those represent a ratio. And again, a ratio is a comparison of a number and a non-zero number using division. Okay, so here.
They can't see because of my hair. That's why. I don't know.
Sorry.
That boy, am I supposed to duck or something?
Okay, so our first one we see it's 60 centimeters to 200 centimeters. So for every 60 centimeters, the other part's going to be 200 centimeters. So we want to reduce this to simplest ratio. So we're going to start that by writing it down in division form. So 60 centimeters divided by 200 centimeters. If you are enrolled in a chemistry or physics class, you probably have talked a little bit about dimensional analysis, which is like changing bases, or units is probably a better way of saying it, changing units. So for here, we're just going to actually just cancel these straight out. We don't actually have to change the units in this one. And then we're going to look to simplify it, so we want to reduce it to the lowest terms. So does 60 and 200 have anything in common? Yeah. What do they have in common? 10 and 2. So 10 times 2 is? 20. So let's take 20 out. So how many times does 20 go into 60?
3.
Okay. How many times does 20 go into 200?
10.
Okay. So over here, what we're left with is just going to be 3 over 10. So 3 to 10 is our ratio. 3 to 10. Our next one we see is 3 feet to 18 inches. They are in different units. So we have to perform that analysis and change them to have the exact same units. You see that the hint is already given there. We have 12 inches in 1 foot. So I am going to convert my 3 feet to inches. So we have 3 feet times 12 inches over 1 foot, which equals 36 inches. So our feet cancel. Okay, and then now I'm going to replace that. That was my numerator. So now I have 36 inches over 18 inches. Do 36 and 18 have anything in common? They do. What do they have in common? 18. You could do 9 and then we could do it in 2 steps. But we know 18 goes, so our units cancel. There's inches in the numerator and the denominator. 18 goes into 18 how many times? 1. 18 goes into 36 how many times? Okay, so you are going to have the urge to drop the 1, but because this is a ratio, you have to have it. So it's 2 to 1, and even though if this was an actual fraction, like we were used to, we'd reduce it to the lowest term, but since it's a ratio, we have 2 to 1. We leave it with the 1 in the denominator. And our last one, we have 12 feet to yards. So we could either change the feet or the yards. We know that there's 3 feet and 1 yard. So do you want to change the feet or the yards? So we're going to change the yards to feet? You want to change the feet?
Yeah,
okay. So we have 12 feet. If that's the case, remember that feet go in the denominator because you want to cancel that unit. So we know that we have 3 feet to 1 yard. We set this up so that our units are opposite of each other so that they can be divided out. We see that 3 and 12 have a common factor. How many times does 3 go into 12? 4. So this is just going to be 4 yards. Okay. Now I'm going to put this back in my numerator. So I have 4 yards over 5 yards. Our units cancel. 4 over 5. Is there anything in common? Nope. So our ratio is 4 to 5. 4 to 5. So for every 4 of one, there's going to be 5 of the other. So it's a 1 to 2, and we know that DF is 45. So we're looking to find DE and EF. So let's take a second and write down the information that you need. So we are going to use this, and we're going to look and see that we can use the segment addition postulate. So back to last semester, way back then, we learned about the segment addition postulate, and then we know that the total length of a segment is equal to the sum of its parts. So we're going to write that out. So I have DF equals DE plus EF. So we know that the two parts added together will equal my entire whole, right? Now we have to look for what we know, and we want to find these lengths. Well, we know it's a 1-to-2 ratio. So for every one part, there's going to be two parts over here. But we don't know how many we have when we're solving for this. So when we don't know something, how do we represent it? We represent it with x. So 1x, or just x, because if it has nothing in front of it, there's an implied 1. 2x, because it's 1 to 2. So notice that those coefficients match up with our ratio here, 1, 2. Now I can substitute in what I know into my angle addition postulate here, our formula we worked out. So we see the length of DF is what value? 45. And then we know that DE is x, and we know that EF is 2x. We're going to combine our like terms. So I have 45 equals x plus 2x.
3x.
It's going to be 3x. I'm going to solve for x, so what I got to do? Got to divide. X equals 15. So, but that's not what our question asked for. It didn't say solve for x. It said find the values of DE and EF. So using that photo, I'm able now to see that DE equals x. And what's our value of x? 15. And we know that EF is 2x. What'd you say? Which is going to be that 30. So our final answer is these two solutions. Do we have any questions to this point? My first step with this would be to draw a picture. I now have a rectangle because we have a perimeter of a rectangle. We know we have length. I'll label it length, width. Okay, so what is the formula for perimeter? Does anybody remember the formula for perimeter? So we heard somebody say length times width. What is length times width? That starts with an A. It's area. Length times width area, but we're not looking for area, right? We're looking for perimeter. So how much wall do we have is perimeter. So if I was going to measure out the length of all my walls, but area is how much floor I had to cover it in, right? So to find my perimeter, it's going to be length plus width plus length plus width. So I could write this formula out as perimeter equals 2 length plus 2 width. I'm going to change that L because it looks weird. So we have to have 2 lengths plus 2 widths to give us that total outside of our box, right? Now we have to use what we know. So we see that it's 3 to 2. But we don't know to what, right? Because this is just our ratio. So again, we're going to be using that x. So length is 3, and we're going to put it as 3x. Our width is 2x. So again, notice our ratio here is 3 to 2. We went to what length was the first one. So the first one here, 3x, width, 2x. It's our second one. It's our second one. Now that we have that, we're going to substitute it into that formula. Everything we know goes into that P formula. So what is our total perimeter? It's 70. So we have 70 equals 2 times x, 2 times L, which is 3x, plus 2 times W, which is 2x. So I'm just taking the values I just came up with, and I'm substituting them into my formula. Now I have to act out the operation. We see that that is multiplication. So I end up with 70 equals 2 times 3 is 6x plus 2 times 2 is, combine my like terms, which are my x's. What do I get? 10x. I want to get x by itself. What do I got to do? We got to divide. We end up with x equals 7. Okay, now that we have that portion, we have to go back and find our length and our width. We have those formulas already written out on our page. We see that length is this and width is here. So I'm going to rewrite those off to the side. I see that length equals 3x. And I know that 3 times my x value, which is 7. And then I have my width, which is 2x, which is going to be 2 times 7. So we know 2 times 7 is 14. 3 times 7 is 'So I would have 21 centimeters on my length and 14 centimeters on my width. So on your guided notes, you should write this. Oh, I'm sorry. I didn't mean to change it. Okay. So you should write this portion here. It's not on there. And these definitions here are not on yours. I find this a little hard to see in this when it talks about the second and third terms. You could also rewrite this as A to B equals C to D. And you see here that these are your means and these are your extremes. You could also see that in terms of that first and fourth being the extremes. Well, you know it's the first term, 1, 2, 3, 4. So these two, and then the other two have to be these two. But I think it's a little easier to look at it in that way. And then if that was the case, I would write it in terms of B and C, and here A and D. Okay, and then our last part on here is the cross product property, which is mean extreme. And the product of the extremes equals the product of the means. So it's AD equals BC, and you see that this is just cross multiplying. And these are our last two examples. So solve for the unknown variables. We just saw on the last page that it was that cross multiplying. And we see that that's really this what's occurring. So we have 3 times 8, which equals 6 times x. You guys need a second to write this down on your sheet. So let's make sure we're getting it in there. This is both of the examples. So we have 3 times 8, which is? Nick will have more confidence. What is it? 24. Divide by 6. 24 divided by 6 is? So x equals 4. We did that one quickly. I'm going to give you a second to write the second one before we get started on it.
That's all we need.
Is this semester going to be easy? You're
Okay. So our next one is cross product. So again, we see that 7 times 8 equals 2 times. You need parentheses here because subtraction is occurring. So 2 times the quantity of W minus 2. What is 7 times 8? So I'm going to move that up here so I have space. 56 equals 2 times W minus 2. There's two ways of solving this. So Nika wants the distributive property. That works for me. So we end up with 56 equals 2W minus 4. Combine my like terms. My like terms are my constants. So that means I've got to do what with this? Got to add to the other side. So we end up with exactly what she said. 60 equals 2W. Got to get our W by itself. So I got to divide. W equals 30. There was another way of doing this. I'm going to do it in red right here. So if you did it another way, at this point, 56 equals 2 W minus 2. I could have divided by 2, which would have been 28 equals W minus 2. Add 2, add 2. 30 equals W. So if that would have been the method you preferred, that was fine.